To imagine the arrangement of the pleura surrounding the lungs, let's use the water balloon analogy, where we sink a fist into a water balloon that's not filled entirely. The water balloon represents the pleura, and the fist represents the lungs. The part of the balloon contacting the fist is the visceral pleura. The outer portion of the balloon represents the parietal pleura, and the air space represents the pleural cavity, which is a fluid-filled space. Taking a look at a diagram, the brown line represents the rib cage, the light line, the parietal pleura, that's lining the rib cage, covering the lungs is the visceral pleura, and then in burgundy is the pleural cavity that's filled with serous fluid. Even though in both of our examples it looks like there is a lot of serous fluid, there's really a minimal amount of serous fluid between the parietal and visceral pleura, just enough so that the two membranes can slip across each other with minimal friction. The minimal amount of fluid between the parietal and visceral pleura create a negative pressure that's responsible for suctioning the lung to the inside of the rib cage. This dynamic is similar to the dynamic between a cold drink on a hot summer day, how it will sweat a little bit, and when you pick up the glass, it will stick to the coaster. That little bit of fluid that's found between the glass and the coaster is similar to the serous fluid. It causes the glass and the coaster to adhere together, just like the lung does to the inside of the rib cage. The two can slip across each other, but it would be very hard to separate the two.